Okay, so today's going to be about why are our cells so small, and just kind of covering, since we've been learning about the phospholipid bilayer, why are cells the size that they are and not bigger or smaller? Why do they stay at their size? So really it comes down to this surface to area to volume ratio. So as we go through this math here, both in squares and circles, we really look at how the surface area to volume changes and how that affects how things move through the plasma membrane and why that's important. Okay, so first we're just going to start out with the simple math. So the surface area of just this square, so here, surface area. So I wrote the equations here, so this would be 6 times 2 squared, so 2 times 2 is 4, 4 times 6 is 24, so 24 millimeters squared. And then volume is cubed, so 2 cubed, 6 millimeters cubed, so that's 24 to 6. Okay, and I'll reduce it down here. Okay, so same with the 3, 6, 3, 3, square, cube down here, squared up here. So this is going to equal 9 times 6, which is 20, or 54. This is 3 cubed, so that's going to be 27. And then 1 by 1 here, so 1 squared times 6 equals 6. Volume 1 cubed equals 1 10 millimeters squared. So 54, 27, and then 6 to 1. And so I'm going to reduce these. So this would be a 3 to 1 ratio. This would be a 2 to 1 ratio, and this would be a 6 to 1 ratio. So we can see already that the square has much more surface area per unit of volume, but as we get bigger, that number is getting smaller. So I want you to look at which one starts off small and which one increases more over time, and really it's the volume. So as we get bigger, volume is increasing at a faster rate, from 1 to 6 to 27, then 6 to 24 to 54. This was a 30 increase, or this was a 21 increase. So it's getting, this one is cubic, this is a cubic function, this is a square function. So in the end, the cubic function will grow faster. Okay, so I'm going to try to run through as quickly as possible the squares here. So basically, I'm just going to fill these in because I know what they are. Surface area here is 50.3. This is 33.5, 1 to 1. And this ratio is 0.75 to 1. So this one is 1.5 to 1. So we can see on the smallest sphere, it has the largest surface area to volume ratio. So why is this important? Really in transport and diffusion, when we cover that, we're going to see that the more surface area you have, the better chance you have stuff of intersecting. So that's why in a digestive cell you have these microvilli, basically purely there to increase the surface area of the cell. So cells need to be so small so they can get gases across the cell. And so just the reason it's smaller is because stuff moves in and out faster, and you have more surface area, more cell membrane per volume to get stuff through. I hope that was helpful.